뭐냐면, 아직 모델을 아직 다 만들진 않았는데, 이거거든요.
Okay. As we, as I announced, this gonna be our Tom project. Uh, Basically, we will design a hydrogen power system for an eVTOL. To do so, we need to understand the eVTOL characteristics as much as you can before we design hydrogen power system. Hydrogen power system will consist of a mainly hydrogen storage tank and also a fuel cell. So uh, this assignment is very similar to the last time. Let me see. I need to. Mm, okay, recording and the shared. Okay. So this assignment, this Tom project is pretty much similar to the last homework, uh, where we design a hydrogen power system for a humanoid. The reason why we are focusing on the humanoid and eVTOL is because these two industry is a really emerging, futuristic applications, uh, and which we as a mechanical engineer can contribute. And also, there will be a lot of job opportunity. So I like to get you familiar with this industry and especially how to design the energy system. Since we are focusing on hydrogen, of course, we like to develop a hydrogen power system for humanoid and also eVTOLs. These two area, the humanoid and also the eVTOLs, happen to be two major future technology being developed by the Hyundai. Uh, I would like to say share. Let's look for the such a technology in Google. Well, as you already know, Hyundai Automotive is significantly investing in humanoid robotics. There are two purposes. The humanoid themselves will be applied to many different industry. And second reason is that they like to use this humanoid robotics for their assembly, auto factory assembly line. Uh, so this include, as he says, developing a robot component, training a robot for tasks like the sequencing part, and exploring the use of a robot for customer service and etc. So we need to understand the what is the current demand and trend of the humanoid, not just for the purpose of understanding of energy, but also mainly to understand the how new technologies are developing. Again, even in Korea, not only Hyundai, but also LG, SK, are heavily investigate on these humanoid markets. And the current humanoid is their power system is the motor and the battery. Battery, there are many different types of battery these days. Not only lithium ion battery, but there can be a lot different types of battery. And it's especially in Korea, we do have a very strong battery industry, such as Lotte, LG, and also SK. Most of the major company, they have a top technology in battery. So in last 2 weeks, through the homework, you have a focus on how to design power system, mainly using the hydrogen for this type of humanoid. But I like to emphasize again, this humanoid is the one has a big market in the future. You can easily find how the market will grow of this humanoid. So regardless, whatever you do as a mechanical engineer researchers, to understand the humanoid robot market and technology will help you to improve your personal capability in research and development. So we have to, it's not a choice, you have to focus working on the understanding humanoid and the market, how the market grows, and what will be their technology, main technology. So is important. Now, as a second market, second technology, which we will like to focus is the eVTOL. eVTOL is again is a technology-wise is mostly developed, but there are a lot of regulations and laws that have to be established for safety purpose. So you can easily find the characteristics of eVTOL. eVTOL stands for the electric vertical takeoff and landing aircraft, eVTOL. Of course, this is the one category of the drone, but eVTOL is commonly used to indicate this electric vertical takeoff. So when you do a STEM project, I highly recommend to study about this market trend and projections, which also you can easily find from internet searchings, and growth rate the market is expected to grow at a very significant rate with some forecast indicating CAGR over 30% is a huge growth. And the valuation by 2034 for next 9 years, I would say the $170 billion, which is a huge number. And factors driving growth, why this eVTOL is developing so fast? Well, market is being driven by the factors such as technological advancement in battery. See, battery development is really helping this eVTOL industry, and electrical propulsion system such as motors. And we like to find the alternative power system. And there are several other factors, and the key player and market size and specific projections you can find. I mean, searching information is no problem, but understanding is the one we need to do. Rather than just the searching and copying the values, we need to understand what's happening in this eVTOL market. Okay, well, before go further, I would like to go one by one from 1 to 7. Well, previously there were 1 to 6, but I add one more item here. Again, design a hydrogen power system for an eVTOL. eVTOL, you can choose your own, but you may choose one of the existing eVTOL, such as EHang EH216, which I would like to show today. So as usual, first we need to estimate a total energy needed for the operation of a eVTOL. Well, I need to delete this one. Say we need to define the role of the eVTOL, specific purpose, what will be the maximum ranges, and then how much the weight and the passengers. So we need to define that. And also we need to estimate the hydrogen mass in kilogram. And because we already have we defined the total energies. Now we need to define the hydrogen mass in kilo, and also volume. And then estimate the power of a fuel cell. And then design of a hydrogen storage tank, which we briefly reviewed in the last class. I know it's not easy to design a hydrogen storage tank, but understanding the characteristics of a hydrogen tank, you can estimate, you can make the several assumptions, and you can come to your own design. Doesn't need to be precisely correct, as long as you have your own proper assumptions. Any design will be okay. And then the size or mass of a fuel cell, I would change this to order, put it here. Well, this is gonna be a 3 and 4. Okay, so 4 and 5 will be relate to a fuel cell, and 2 and 3 will be relate to a hydrogen storage tank. And then compare between the hydrogen and battery systems. This is important to understand. The reason is that battery power system is already well established and almost fully commercialized. Now, as a alternative power system, we like to develop the and propose hydrogen power system. To do so, we need to understand, we need to be able to, should be able to compare between these two power systems. So it is important to compare them. And then and the last item, I just make the comment here. You can choose your own eVTOL, or you can work on the EHang EH2216. Your own eVTOL means that you can define the number of passengers and total weight of the eVTOL and the maximum ranges of flying based on those characteristics, and then you can come to more detail about the specification of a hydrogen tank and also a fuel cell. But you may prefer to start with existing eVTOL for your convenience. Okay, so this is a very broad, as you already noticed, that very broad assignment. Main point is that we need to should be able to start from a very basic requirements, and then we like to boil down to more specific designs. So I know is again the very tough assignment for a term project. I would say I like to start with market size. Which we just went here. And before we moving to the specific assignments, we first need to like to consider what they are saying through the internet searchings. So the eVTOL power system, and then let's see what they are saying that. We don't want to just copy and paste. We first need to understand, this is very important, understand the characteristics of eVTOLs and power system. So again, this is important rather than just searching, copying, and paste. eVTOL primarily use electric motors, exactly same as in the fuel cell vehicle. We use electric motor powered by battery for propulsions, offering advantage like reduced noise and emissions. see this eVTOL. Let's say instead of eVTOL, you can say fuel cell vehicle. Exactly same. Primarily use electric motor and by batteries, and there are some advantage like this. Okay, so this system, either fuel cell vehicle or humanoid operated by the power hydrogen or eVTOL, will include the battery, motors, and power electronics. Is crucial for achieving a vertical takeoff and landing. Okay, this eVTOL is a vertical takeoff and landing, as well as the flight, battery technology, particularly an advancement in energy density and efficiency is a key factor. Now, let's try to understand this mechanical system, such as the vertical takeoff and landing. What does it mean, and how much the energy we need? So I would just say like this, vertical takeoff and landing eVTOL. So eVTOL certainly stands for the electric vertical takeoff and landing. And it refer to, actually, it's not just for the drone-like eVTOL. This technology has been successfully developed for other airplane as well. So it referred to aircraft often called air taxis or flying taxis, something like the helicopter. Why do we need this vertical takeoff and landing? What will be the advantages? Vertical takeoff and landing. Well, this way we don't need any large space of the landing and takeoff, right? So to be used in the urban air mobility UAM or advanced air mobility AAM, this eVTOL takeoff and landing is the critical. Let's say any eVTOL will be okay, but let's watch the one of them.
Electric propulsion. The Fly-Free eVTOL is designed to be quiet, efficient, and environmentally friendly, making it well suited for use in densely populated urban areas. It is capable of
See, as you can see here is a vertically takeoff. As you can see that.
carrying passengers or cargo with a range of up to 100 miles, 160 kilometers on a single charge, and a top speed of around 100 mph, 160 km/h, depending on the model. One of the key features of the Fly-Free eVTOL is its autonomous flight capability, which allows it to be operated with minimal pilot input. This makes it easier and safer to operate, while also reducing the cost of operation compared to traditional manned aircraft to operate.
Now this, as you can see, the this propeller in the takeoff or landing, this direction is toward the vertical direction, and then while we are flying, then this direction will be almost parallel. So it's important to understand why this propeller is direction is changing for different flying status.
While also reducing the cost of operation compared to traditional manned aircraft. Overall, the Fly-Free eVTOL represents a new era in urban air mobility, offering a sustainable and efficient way to transport people and goods in crowded cities.
as you obviously, while they are flying, the direction of a propeller is moving in the direction of flying rather than vertical directions. This is very similar to a regular the aircraft, but again, all the propeller, not the jet engine, propeller type, mainly because this old propeller is operated by the motor, electric motor, which is also one of the key components. As you can see, the direction of this propeller plane is not just the vertical, is not just the direction of flying. It has a certain direction. Means that the force we need to have is the two component. One is the vertical, and the other one is the forward. So since this propeller can be moved, the direction of a propeller can be moved. So depending on the flying conditions, we can change the direction. This is the very important technology. Actually, this eVTOL, as you can see here, is called Joby. Joby is the one of the largest eVTOL companies, which get a lot of funding from outside, and we hope to have such a large company in Korea, in Asia as well. As you can see that, vertical takeoff and so we don't need much space. So we can just take off, landing in the top of the buildings, in any limited space in the urban city. This is the one of the key. And also these days we have we got the technology of the advanced navigation system. So that will also help. This technology is practical. Okay, well, let's move to one more video. And Joby, actually the same as this one.
Say hello to the future of flying. This is the Joby Electric Air Taxi. An eVTOL that takes off like a drone and cruises like a plane. Quiet, emission-free, and built for your daily commute through the sky. Skip the traffic. Soar above it all at 200 miles per hour. Powered by electricity, Joby covers up to 150 miles on a single charge. Designed for urban air mobility, landing wherever space allows. The race to make flying taxis real is on, and Joby's leading the charge. Ready for takeoff? Stuck in traffic for hours? Or flying to work in just minutes? With advanced flight controls and autopilot tech, Joby keeps you safe effortlessly. Silent skies, clean energy, and zero emissions, the future is taking flight. Land right in the heart of the city, no runways needed, just a pad and clear skies. Big windows. Big views. A ride that feels more like floating than flying. Fully electric. Quiet. And built to run on clean energy. Already making waves in major cities. The air taxi revolution is here. Ready to fly above the noise? Joby Aviation is not a dream, it's your next ride. While they're stuck in traffic, you're already halfway across town, smooth, silent, and stress-free. Commutes that used to take an hour? Now just 10 minutes. Seriously. Flown by top-tier pilots with cutting-edge flight control systems. Safety? First class. Ultra-quiet design means no noise pollution. Cities stay peaceful while the skies get smarter. Backed by years of R&D, Joby isn't just a prototype, it's FAA certified and flight ready. 100% electric. Zero emissions. A new era of transportation that doesn't cost the earth. The future? Aerial highways in the sky. And Joby's leading the charge. Say hello to the future of
Okay, since it is a so important educating video, I like to replay again. Okay, just 1 second. Annotation. Okay.
flying. This is the Joby Electric Air Taxi. An eVTOL that takes off like a drone and cruises like a plane. Quiet, emission-free, and built for your daily commute through the sky. Skip the traffic. Soar above it all at 200 miles per hour. Powered by electricity, Joby covers up to 150 miles on a single charge. Designed for urban air mobility, landing wherever space allows.
That was a little bit wrongly transcript. It's not the, it is a 150 mile on a single charge, okay, 150 mile, which will be about 250 kilometer, okay, I mean, which is very much long enough to cover most of commute and the but I'm sure the range will be extended with the technology, especially a better power system such as hydrogen. With the hydrogen, full hydrogen power system, the range will be can be doubled. Imagine this eVTOL can be lighter, can fly longer with one charge. That is our dream, and can be also safer. So there are a lot of advantages with the hydrogen power system.
Landing wherever space allows. The race to make flying taxis real is on, and Joby's leading the charge. Ready for takeoff? Stuck in traffic for hours? Or flying to work in just minutes? With advanced flight controls and autopilot tech, Joby keeps you safe effortlessly. Silent skies, clean energy, and zero emissions, the future is taking flight. Land right in the heart of the city, no runways needed, just a pad and clear skies. Big windows. Big views. A ride that
So as you can see easily, the weight of this eVTOL is critical in terms of saving energy. So the older structures should be or can be made of the composites, very light composites, such as the carbon fibers and some resin systems. And again, this structure should be lighter to extend more flying ranges and saving more energies.
feels more like floating than flying. Fully electric. Quiet. And built to run on clean energy. Already making waves in major cities. The air taxi revolution is here. Ready to fly above the noise? Joby Aviation is not a dream, it's your next ride. While they're stuck in traffic, You're already halfway across town, smooth, silent, and stress-free. Commutes that used to take an hour? Now just 10 minutes. Seriously. Flown by top-tier pilots with cutting-edge flight control systems. Safety? First class. Ultra-quiet design means no noise pollution. Cities stay peaceful while the skies get smarter. Backed by years of R&D, Joby isn't just a prototype, it's FAA certified and flight ready.
It is important to take a note that this Joby is eVTOL has already FAA certified, and for any commercial product to be commercialized, we need to have a certifications. So it is already FAA certified, and means that the safety is already confirmed and verified, is important for business.
100% electric. Zero emissions. A new era of transportation that doesn't cost the earth. The future? Aerial highways in the sky.
Well, this is not a dream. This is a reality. Shifting from the vehicle type transportation to a aircraft like the eVTOL will be is a reality. It's not a dream. So we engineers need to prepare to make it happen, and contributing our society to develop our energy and experience to more advanced, more economic, cost effective, and of course the most importantly safer flight system.
And Joby's
Okay, let's say I like to share this copy to our Okay, now, well, as I mentioned, there is another one, is EHang. EHang eVTOL, and let's take a look at this, some promoting video. EHang model number is EH216S. Again, is a complete world first eVTOL. Let's take a look at. Well, as you can see that EHang, the technologically same as the Joby, but there is a big difference. The difference is that the direction of a propeller does not change. Well, this indicates the
年，我们改变了一个行业。 让飞行更加智能，让航空普惠每一个人。现在，我们要用飞行去创造一个全新的绿色交通，用清洁能源让天空更加蔚蓝。
就绪，起飞，开始计时。
好，看到了啊，看到了。
Well, this video is about the EH216 flight endurance verification test. That's why we keep making circles to verify their flight endurance. But anyhow, let's get back to several others. Pilot list has successfully. See, this is another very promising technology of the this eVTOL. There is no pilot. There's no pilot. Pilot list is a similar technology applied to automotive. As you can see, the major and big difference between this EHang and Joby is that the propeller, this one is a fixed wing, fixed, and compared to a movable propeller system in Joby system. So there's a big difference. So the whole eVTOL flying system needs to change the depending on the your flying status, but which is still very much okay. This way it can be much simpler than a Joby system, and in terms of cost and in terms of maintenance. Well, EHang is the is a Chinese company and launched more than 10 years ago, and now is fully successful in commercializing this eVTOL. And again, the structure is mainly made of the carbon fiber reinforced plastics and currently battery system, but our contribution can be to convert the power system into a hydrogen. So let's again through this TOM project, we try to understand power system of EHang, and I mean you can choose the Joby. Is no problem. Either Joby or EHang. These are two most promising the eVTOLs, which you can improve by providing or designing a power system or energy system using hydrogen. Okay. So now let's get back to the let's say, okay. Oops. I mean, you don't have to use the ChatGPT. You can choose any AI system to effectively search for the informations. But you can direct. You are the designer. You are the principal investigator. So you need to have all the direction and all the you need to guide. Don't let AI guide you. You need a guide and communicate with any AI tools such as the ChatGPT or Grok or Gemini. Gemini has become very much powerful in AI tool as a AI tools. So Gemini is also highly recommend. So anyhow, I just create a project called Hydrogen for eVTOL, and I like to let's say technology between I would say eVTOL. We watched two commercialized eVTOL, EHang and Joby. But let's say let's compare that. See, it's important to compare two products when you start to develop a your own system. So comparison is a good start of the understanding the technology, not just for the purpose of compare, but it really helps us to understand the eVTOL in general. So, well, here is a detailed comparison of eVTOLs, electric vertical takeoff and landing, technology between EHang and Joby Aviation USA. Well, technology-wise, advanced technology led by the USA, led by the China. There's a two big, movers. It's important to compare them. Now, vertical configuration and design. Vehicle configuration and design, vehicles. So EHang, as we watched, the configuration is a multi-rotor. Octocopter, what does it mean? We have 8 helicopters, eight motor system. So we call octocopter design. So it is a multi-rotor. And now this tilting, as you watch that, the rotor can be tilted, can be movable from horizontal to almost vertical. So we have 6 tilting propellers. This is important comparison. And seats, how many can be a passenger? Seats is just a 2-person, 2 pilot and passenger. So 2 persons, 2 seats. And then 4 to 5 with the pilot. So I would say 5 passengers. And wings, there is no wings in EHang, just a pure multi-rotor. And the Joby S4, model is S4, is the fixed wing. Direction of a wing is not changing, but the rotor is tilting, can be tiltable. So, and control, fully autonomous. See, autonomous means that as you watched, and we don't need a pilot, and they are already fully developed, these autonomous control systems, very similar to the case. So what's going on in the autonomous driving vehicles. And this is a very important futuristic technology, autonomous. But the Joby S4 is not autonomous yet, but we need a pilot initially, and then can be set to automatic flying, so autonomous later. So it is not the full autonomous system. Target use. Well, this is urban air mobility and short trip, and this is a regional transport, longer trips. So this is again the longer and shorter. Let's see more characteristics. And cruise speed, EHang is about the 81 mile per hour, which is about the 130 kilo per hour, which is very fast, right? Considering the speed of a vehicle, regular vehicle, such as the 100 kilometer per hour, now it can fly like the 130 kilometer per hour. Now, Joby system, wow, is very fast, 200 mile per hour or 320 kilo. Why this is possible? Well, this is mainly because the tilting rotor. Tilting rotor means that when it flies, the rotor is in the direction of flying, so it can fly very fast. That's why it can be applied to a longer trip, whereas the EHang is for the short trip. And the flight time is about the 20 minutes versus 60 minutes. Maximum range is about 35 kilo versus 240 kilo, which is really long. And redundancy, high redundancy via 16 rotors, and redundant system with a tilt rotor system, and noisy level, moderate and very quiet. That is not the major point, but this is the technological flight comparison. Now, this is important, propulsion and battery systems. EHang, it has a 16 fixed rotor. Actually, why is it 16? Even though it has a 8, where is it says? Octocopter, 8 design multi-rotor, because we have a top and bottom, two. See, we have a top and bottom. We have a separate motor system, top and bottom. So this is also important. That's why we have a 16 motor system. Uh, 16 fixed rotor, and whereas this is the 6 tilt rotors. Battery type, lithium-ion battery, and proprietary high energy lithium ion packs, but it is still lithium ion battery. Okay, and charging, ground charging or fast charging. While this is similar to the electric vehicles, can be regular ground charging or fast charging. Regulatory status and certification, we need to pay attention to certification they get for the commercializations. CAAC is a certificate for the flying cars. And then FAA, they already got the FAA certifications, and the flying test 30,000 plus autonomous flights and so on, and autonomy approval, and also commercial readiness. Well, EHang is almost commercialized, ready to sell. Asia urban air taxi market and China plus, and then Joby is a USA regional air mobility, and the partnerships and so on, and business model, EAM, and the company background. And yeah, we engineer also need to pay attention to a business aspect, not just the technology. We need to open our eyes to the business aspect as well. See, this one is a Nasdaq. This is a New York IPO. And as you can see that how much the money they get investment. And the strengths and limitation. Limitation of EHang is a very short ranges. We don't have no wings, but the so it's good for the short CT. Okay. Now I would like to. How about the eVTOL? They call AAM. Hyundai also has a long plan. Hyundai Motor Group is developing eVTOL, AAM, Advanced Air Mobility Platform. And yes, you can get the more informations, and the actually the company name Supernal. This is the part of Hyundai Motor Group, and eVTOL has a name, and tilt rotor plus a fixed wing, a hybrid, 4 passengers, and the cruiser speed and range and flying time, and all depends on the power system as well. As you can see that technology and design approach and propulsion system. I highly recommend you guys to compare all the technology among these 3 eVTOLs. It's not difficult at all. You can collect most of the informations from searching through AI tools or Google searchings. So the by comparison, again, as I mentioned, emphasize by comparison, you can understand very well. Now you have a Supernal S-A2 compare with the EHang and Joby. You can have a seats, and the it is important. So Hyundai unique edges, unique technology. What's good? Well, integration power. Now, Hyundai can combine air and ground mobility using its global automotive expect multifunctional muscles. And the I like to see Okay. Actually, I like to emphasize the how about the power system of the Hyundai eVTOL? Now, Supernal or Hyundai is designed with a distributed electric propulsion system. And the while they are using the battery system, but they also another activity using the hydrogen. Yeah, you can. Well, it simply says the lithium ion proprietary battery type. Here again, I just like to go through all the background of these eVTOLs and mainly focusing on the power system. Using hydrogen energy in eVTOLs aircraft is an emerging but a promising pathway to extend the ranges and reduce battery weight. See, is important. Using hydrogen energy in eVTOL we can reduce the battery weight, enable sustainable aviations. So why hydrogen for eVTOLs? Well, hydrogen is a 3 times more specific energy. You know, what does it mean, the specific energy? Specific energy means that the energy can be 3 times of more energy can be saved per kilo. Okay, per kilo. Rather than I'm compared to lithium-ion batteries. So and also importantly, the lightweight structure itself can also contribute to saving energy as well. So with the same weight, we can fly about 3 times more flying ranges, which is very much significant. So you can see that how hydrogen power can be very light compared to a very heavy battery system. Power system, where hydrogen is, we already know the principle H2 plus O2 giving us the water and the motors and pros and cons and challenging and etc. So hydrogen combustion, well, this is a little different technology. Instead of a fuel cell, we can use the hydrogen combustion, internal combustion engines. But at this point, we can use the fuel cell system. So eVTOL companies exploring hydrogen. See, eVTOL companies exploring hydrogen. And there are several companies, they are exploring to use the hydrogen system under certain projects. So we should understand why so many companies are trying to develop hydrogen power system for eVTOL. Well, they are not fully commercialized. They are exploring the hydrogen. What does it mean? Since it's obvious that we can have a lot the advantage with hydrogen. Hydrogen storages and weight and volumes and thermal management and safety and certifications. This is also important. concept, hybrid hydrogen battery. Well, there can be another system called hybrid. Hybrid means that we will have a hydrogen, gas, and battery together. So energy control-wise, we can use both hydrogen battery, but depending on the power requirement, we can alternatively use this power system, and eventually we can increase the increase the efficiency. See, use of fuel cell for cruise power, which takes less power, and then use a battery for peak load. So that is the hybrid. You know, even for the regular vehicles, hybrid system is a way we increasing the efficiency. Same for the eVTOL. So future outlook, 2025, and this is a current, present, and this is in next 5 years and 10 years. So certification of fuel cell based eVTOL for short ranges, and then H2 infrastructures. See, as you can see that the main reason why eVTOL are using the battery is not because the battery is better than hydrogen system, but because the battery power system is fully commercialized. So that's the reason. But once the hydrogen power system are fully developed and commercialized, there are, eVTOL will use the hydrogen rather than battery or hybrid system. So this is a very important factors why we need to develop the hydrogen systems. Okay, so summary in general, as you can see that the flying range is about 3 times hydrogen eVTOL. And the refueling time, what does it mean? To charge the battery, it takes the hour. But charging the hydrogen, it takes like the minute, about 10 minutes. It's similar to a gasoline fueling system. And this is a similar, battery is similar to automotive. And energy density low. What does it mean? Per kilo, we have a low energy capacity, but hydrogen can have a very significant energy density, high energy density. And again, with this lightweight, it saves energy as well. Not only the weight itself of the power system, but with this lightweight, it can extend the flying ranges. Okay, infrastructure. This is an important point, and this is emerging, and this is the very early stages. But you can see a lot of companies are already started to develop hydrogen power system for the eVTOLs, and compared to Joby and etc. So it is important to understand the background of these eVTOLs. Even though we are mainly focusing on power system, but understand the general aspect of eVTOL and what can be better with hydrogen is important. Okay, now all our lecture through this Zoom is being recorded. I didn't upload the last class yet, which I will do very soon. And today class will be uploaded as well. Now, I just like to add one more thing. we can estimate. How can we estimate the power system of a eVTOL using the hydrogen? That's the key part in our TOM project. So, well, I'm sure that you're gonna communicate with ChatGPT or Gemini is no problem, and is highly recommended. Without searching through AI tools is a smart way. But the main point is that don't just let them design and go through all the directions. You guys need to communicate and giving them directions. You as a principal investigators, that is what you need to do in future, how to use the AI tools. So anyhow, let's say oh man, energy and power system. Okay, this can be very fundamental question you can ask to the AI tools. Please give us some direction of how to design the energy and power system in eVTOL. Okay, let's see what they are saying that. Designing an energy and power system for eVTOL aircraft involves balancing performance, safety, weight, and mission profile. I know this designing of a power system is kind of a new area to each one of you, but it's important to adapt to a new requirement as an engineer. You can how fast you can learn, how fast you can apply existing or combining existing or new technology together. So anyhow, exam value. See to before selecting energy source, this is the most important point. Before selecting energy source, we need to define the eVTOL's operational parameter. Let's say you are the designer of the power system for the eVTOL in a Hyundai or any other company like the Joby or EHang. Now you are assigned, for example, you assigned to design a new eVTOL and the power system. So first you need to define the characteristics. How long is the flight time? Is it 20 or 30 minutes or 60 or 90 minutes? This is your own choice, depending on the application. Is it urban application or just regional applications? And cruise speed is also important. How fast are you going to design? And it's going to be about the 150 kilo per hour or 200 or 300 kilometer per hour. Ranges is important. Payload, okay, payload. How much, including the weight of the structures and including the pilots. So you need to estimate, define this kilo and operating altitude, how high you can fly, say 300 to 500 meter high or 1,000 to 3,000 meter. Recharging and fueling time. We like to have a very fast charging time or or charging time is okay. We need to define. Now you can select battery or hydrogen and so on and estimate the power requirement. And again, I'm sure you can get some numbers and characteristics from this information, but I'm sure this will gives you first the values and things like that. But the most important point is that say okay, this is important as we the several weeks ago we defined the this table to for the energy capacity and power capacity. See, energy is energy and power. We need to define this percentage of each flight phase, like the takeoff is in terms of percentage of total energies, and climbing and cruise and descent and landing and reserve margin. So this has to be defined. And this is the depending on your flight, your purpose of eVTOLs. It's gonna be urban uses or regional uses. So you can estimate, and now you need to define a values for each, assuming the conditions and the flight phase and power needed. And now takeoff and the landing, takeoff is the most requiring high power, and the climbing moderate, and cruising standby power, and then descending and landing is low. The reason is that this the self weight will be the one descending and landing. So again, when you design the power of the fuel cell, you need to consider takeoff, and the that is the very critical one. And the basic calculation. See, this is the key part in calculations: required thrust and rotor efficiency. And you need to consider the rotor efficiency and flight time and the reserve. Okay, so there are many factors, and specific power and the lifespan. And I'm sure they will this system will give you some information, but you need to go into more in detail by communications. Okay, so the I don't want to go through all the direction of designing of a hydrogen power system, but I just like to give you the idea of this power system of eVTOL using hydrogen systems. Okay, so the you can have a simulate and optimization tools like the MATLAB or ANSYS and Console, where you can use the computational tools, but the main reason why we may need to use this simulation is for the purpose of optimizations. Optimization is that, we like to make it the eVTOL as light as possible, as taking as a most least amount of energy and power, then we need to define the motor and the and so on. So the again, you may choose the either existing one, EHang or Joby. It's up to you. Or you can have your own eVTOL. Is no problems. I will like to change it here. You can choose your own eVTOL. Okay. Okay. And the well, today I would like to finish the class by say 4:30 in several minutes, and the this will be again review to all term project and clarify the how you define the preliminary design of hydro systems. Well, I hope to have your feedback or questions. But again, you can contact, leave a comment through Katalk. I will save all the conversation I made here into our PowerPoint. Okay. For example, well, I can ask. Well, actually, you don't need to read this summary, which was done by others. You can easily do yourself, and then in your own. And when you save the Microsoft Word file, you always need to double check whether all the information are properly saved. I often notice that this eVTOL, energy and power system, and mission profile, and select, estimate, and the design, and so on. Okay. This is certainly the one of the this word file they doesn't have the comparison between the existing eVTOL. That's why I ask to include all the comparisons. But again, these see now they updated the Microsoft Word file, and EHang and Joby and Hyundai all together, and certainly this will help us to better understand eVTOLs. Well, not much further informations are added. Oops. Let me open again. See, don't trust these things. One thing I like to emphasize in saving all files into Microsoft is that they often make a big mistake in this AI tool. Oh man. Okay, now it contains all the comparison and characteristics and power system, and then a summary. Man. So these are separated. Well, this is not so important. I just want to emphasize that you can use all the informations, and then I can just share this file just for the purpose of savings. Here, this is a comparison, and this is the I would say how to design of the power system. Okay, but again, I like to emphasize that you need to be PI, principal investigator, design of a hydrogen power system with your own will, rather than just being led by the AI. Okay, so I'd like to close today's class. I know it's a little early, but this is enough for you two guys to complete the term project, which will be due next Wednesday. Okay, don't forget, due is the next Wednesday, 11 p.m., which gives you one more day. Okay, I mentioned here 11:59 p.m., 11th of June, Wednesday. So this 1 minute before the Thursday, so which is due. And this, I'm sorry not to emphasize how the grade is go on, but the grade will be based on your weekly homework and the term project. This is gonna be a 40%, and the homework will be 50%, and the 10% is for the attendance. But I'm sure that you can watch the any missing class. So don't worry about this attendance as long as you go through all the classes. It's based on trust. So please pay much attention to this term project to make up all the classes. Okay. Thank you so much. And I'd like to close the this semester and 1 week before because I need to have another keynote speech in conference. I hope that I mean, in this class, I don't mean to give you full detailed knowledge on the hydrogen system, but I like to give you some insight and on the this hydrogen power system. So to help you to prepare for future technology, and then I hope that you can contribute to your efforts to society, and then hope that you can get a better job, so you can work in any companies you wish to contribute. Okay, but again, the industry out there is not easy, very demanding. So if you're not prepared well, you will be easily get behind. So put a lot of effort to prepare for this hydrogen technology. Okay, well, thank you so much, and then all the wishes go for you. Thank you.